Hello everyone. So in today's video we are going to discuss the problems of the GTA paper held at Narayana Institute. I received this paper or some doubt problems through the emails and WhatsApp what I have shared on my YouTube channel. I don't know what the GTA number, but I have selected few questions to discuss in this video. So the first question, as we can see in the screen, is an integration pi by 4 to pi by 3 sine cube x minus cos cube x cos square x and so on. And we have to establish this integration so that we can integrate it, and then we have to find out the integral in this form here, and after that we have to compare a, b, c and d. So for that, of course, we have to think how we set up the integrand so that we can substitute something easily. You notice there that the power of the sin x and the cosine x in denominator is 2027. So it is inviting us to think in this way, that can I not just take let me write this limit first, and this sine cube x minus cos cubed x minus cosine square x, and I'm borrowing only two terms or two factors of sine and two factor of cosine from here to give to this bracket. So I'm writing there the sine squared x into cos squared x, and in the numerator here I will have the entire thing like this: the sin x plus cosine x plus cosine square x, and in denominator I have again sin x into cosine x and the whole power 2025, because already we have borrowed the two factors out of it. After that, there is no such big thing, because here we have to just separate the terms and see what is happening. So let's first write this is pi by 4, this is pi by 4, then pi by 3, and this thing I'm distributing again, so that will give you sine cube x by sine square x cos square x. So these two terms I'm collecting, so of course one sine x will remain on the top and denominator will be cos square x. So we get here sine x by cos square x, which is nothing but sec x tan x or tan x sec x. Here there is a cos cube x, so same thing will happen, but it is now cosecant x cot x, and this thing will become cos square cancels, will become cosecant square x, so cosecant square x, and here again we can separate it, so it will become sec x, then cosecant x means this one, and again this will become this one cos will cancel, so we get cos by sine, that is cot x, and the power is 2025 and then dx. Now notice it's a easier substitution we have now, because this thing we substitute as soon as t is derivative is already seen in the integrand form, means the factor. So we take this t, and but at the same time we will change the limit. So t I'm taking as secant x plus cosecant x plus cot x. So dt will become the exactly same, that is secant x tan x minus cosecant x cot x minus cosec square x, and this is dx. Similarly, if I have to substitute the bounds, I have to substitute this value there. So at pi by 4 means, let me just state the integration. At pi by 4, what we get? Sec pi by 4 plus cosec pi by 4. So at pi by 4, the upper bound, the lower bound, a will be what? Sec pi by 4 is root 2. Again cosec pi by 4 root 2 and 1. So it will give 2 root 2 plus 1. And at pi by 3, that is going to the upper bound. So sec pi by 3, that is 2 cosec pi by 3, that is 2 by root 3, and cot pi by 3 is 1 by root 3. So this will turn into 2 plus 3 by root 3, that is 2 plus root 3. So it will become 2 plus root 3. And now I have the integration is t to the power 2025 and dt. So this will give you 1 by 2026 t to the power 2026, and the bounds are 2 root 2 plus 1, 2 plus root 3. And after that we substitute everything is so feasible that we can simply compare. So the d value of force, because denominator is 2026, so d value will become 2025, and similarly we compare all those things and we get the answer. The one thing I want to say, that if you substitute this bound here, 1 plus 2 root 2 there, so it will turn into 1 plus 2 root 2 to the power 2026, but here root c, so 2 root 2 you can write as root 8. So root 8 means root c, so c can be compared as 8, not 6. So I think this was not so difficult one, but maybe the student who have sent it to me was confused here somewhere how to separate, but it's not the like a what we call the fallacy of the concept or anything, because sometimes in examination it may happen. All right, let's do this question. This question says that I have 4 numbers first, a, b, c, d, and it says that a plus 1, b plus 1, c plus 1, d plus 1 is 3, a plus 2, b plus 2, c plus 2, d plus 2 is 7, and so on. So of course what we can think that this can be, these values 1, 2, 3 are the placeholders for x, means we are substituting the substitute for the x. If I make it general, so what I can write is the function fx is nothing but x plus a, x plus b, x plus c, and x plus d. So what we can observe that the f1 is 3, f2 is 7, f3 is equal to 13, and f4 is equal to 21. If you are practicing this what we call the solving question of JEE mains or JEE advanced level, you might have encountered this kind of situation or the questions in polynomial, that sometimes we write the polynomial in the factor form plus something, so that this will give you in the form of a series, like f1 is 3, f2 is 7, and so on. So can I not say that this fx can be again equivalently written in this format, that since I'm substituting 1, I should get 3, so I'm taking x minus 1 as a factor. And notice that if you take this format, the leading coefficient is 1 there, so there is no problem here. So, and the second factor I can take x minus 2, then x minus 3, then x minus 4. So now this at 1, this is going to be 0, at 2, this is 0. It means I need to have some other pattern here in terms of x, so that I can substitute 1, 2, 3, 4 to get 3, 7, 13, 21 respectively. So do you think that if you substitute 1, I should get 3, then 2 for 7, 3 for 13, and so on? So don't you think that this we have seen many times? If not, then you can think that 3 minus 7 is 4, 13 minus 7 is 6, and 21 minus 13 is 8. So it's a kind of method of difference process. We have to find the differences in AP, and then we can find the term. But you might have encountered this situation many times, and you can simply crack this as x squared plus x plus 1. Now notice, if you substitute 1, that will become 3, because all that this factor is going to be 0. If you put 2 there, that is also 0, but this will become 4 plus 2 plus 1, 7. If you put 3 there, that will become 0. So 9 plus 3, 12 plus 1, 13. And you put 4 there, that will be 0. Then 16 plus 4 plus 1, 21. It means these two functions are the same. What they're asking is the number of positive integer or integral divisors of a plus 5, a plus 6, b plus 5, b plus 6, c plus 5, c plus 6, d plus 5, d plus 6. So how do you find that a plus 5 and so on? So you notice what is happening there, that if you take this thing together, all the a plus 5, b plus 5, c plus 5 and d plus 5, it is actually a sort of understanding we have that we have substituted this thing. Let me mark it. Means this, all the red ones are nothing but the substitution of 5 in this fx equation or fx expression. It means we are actually finding, let's say this, let's call it this expression. So this expression E is nothing but f5 into f6. So f5 and f6 means, of course, we don't have to now substitute f5 and f6 in this equation or this definition. We can instead substitute f5 and f6 here. So what we get it here, f5 and f6. So it's easy. f5 is nothing but, this is 5 minus 1, 4. So let me calculate. 4, 3, 2 and 1 plus 25 plus 5 plus 1. This is the value of f5. For f6 we get here 5, 4, 3, 2 and 6 square, 36 plus 6 plus 1. And so what we are getting here, 24 plus 31. And here 120 plus 43. So we are getting here 24 plus 31 is going to be 53, and this is going to be 120 into 161. Now 53 is a prime number and 161 is also a prime number. I think it's not divided by 6 plus 2, 8. No. So these two are prime numbers. So we have the power 1 and 1. So prime total number of divisors or the factors are given by 2 into 2, because this 53 can come in two ways in the divisors. To make divisors, either it will come or it will not come. Similarly 161 can come in two ways, either it will come or not come. So it will become 4. Okay. So this was another question here. Now let's move to this question.